This morning, we're with Ms. Thomas's sixth grade in Czech Elementary in Floyd County. And we're meeting with a group on a project called Time Garden. So I have Zach Dewar, Charles Nichols, and Scotty Hardwig are the team for Time Garden. So I'm going to turn it over to them.
Hi, everyone. Thanks for joining us this morning. So again, I'm Zach, and I'm a visual artist that works at Virginia Tech.
Sure. My name's Scotty Hardwig. I'm a dancer and choreographer, and I teach movement and dance at Virginia Tech.
I'm Charles Nichols. I'm a composer and violinist and computer musician.
And we've been working together for the past year on a project that we call Time Garden. And we're going to play a little video about that. So this is something that is for virtual reality. So it's where you put on a VR headset and you'd be able to see inside the virtual world. And this video is going to talk about our process of making this and collaborating together to make this art project. And also it's going to show you imagery from both the process and some of the completed works. It's still in progress. I think we're finishing it this year. So.
Hi, everyone. So we're here today to talk about Time Garden, which is a choreographic work operating at the intersection of physical and imagined virtual spaces. The piece takes place entirely in virtual three-dimensional space for VR, and it combines the art forms of dance through motion capture, music, visual art, and digital animation. So in some ways, this piece began back in 2019 with a live performance work called Body Full of Time, which had a section of interactive dance performance with live motion capture that was then mapped onto a huge avatarial body and projected behind the dancer. And it was coded to respond in time-delayed and fragmented ways to my movements. And then we thought maybe we could use this same approach for a performance work that would take place entirely in virtual reality. And the seed of that idea became the premise for Time Garden. We imagined it as being a three-movement piece, each section corresponding energetically or ritually to a time of day. And so we have three distinct movements called morning, noon, and night. For each of them, we started with motion capture of my movement and then mapped that movement onto different avatars that feature different layers of human anatomy. There's also something that's interesting to me about the replication of my body into multiple bodies. Basically, these are choreographic events with ensembles of bodies composed in virtual space, but they're all my body, they're all me as a performer. And yet at the same time, they also aren't my body. So taking movement out of context in a way. And there's something both real and hyper-real, surreal maybe, about translating choreography from corporeal body to virtual body.
I composed the music for the first movement, Morning, by mapping streams of motion capture data from Scotty's dance recordings of the position of his head, sternum, wrists, elbows, knees, and ankles to audio synthesis parameters. For instance, I mapped head Y position to overall amplitude, so the taller the dancer, the louder the sound. I worked with 3 of Scotty's dance recordings that Zach formatted into a Unity app that streamed 3 sets of data using OSC and received the OSC data from these 3 dance recordings in Max programming that scaled and mapped the data to expressively control the parameters of the granular synthesis that I programmed in the same patch. The patch applied granular synthesis to samples I recorded of student composer and a cappella singer James Gilchrist singing long tones on the vowels A, U, and E over the chromatic pitches of his extensive range, and reciting a poem that Scotty composed during one of our early project meetings in medium, low, and high voices. To make the samples of text more noisy, to contrast the sung pitches, I deleted all of the vowels in the text recordings, leaving only the consonants. I generated 2 sound files for each of the 33 dancers, who are distributed along the path of the camera in the Unity virtual environment. The 3 dance recordings alternated between the 33 dancers, producing variety in the animation and granular synthesis timbre as the camera moves along the path. The different pitch and text phrase sound files attached to each of the 33 dancers produces a melodic progression or harmonic motion and a variety of noisy textures as the camera moves past the dancers. As the lymphatic system accelerated, more vocal samples were triggered, and the audio delay feedback increased, producing a more sustained version of the jittery textures.
So our process started somewhere between choreography, systems for processing that choreography in virtual space, and virtual environments in which the choreography would take place. We developed all 3 of those together. The new motion capture gloves were designed for live VR use in Unity, but didn't come with any recording capabilities or plugins for any animation recording softwares. They were just for live use. So we rigged together a system in Unity for recording the real-time movement of the fingers, while simultaneously the software for the motion capture suit was recording the movements of the rest of the body. In the end, we landed on a set of movements that didn't play so directly with hyperreality in the body, but instead the movements create a sort of sacred dialogue with an impossible set of virtual environments that are also formed out of the body. I think it took us a while to all realize together we didn't need a fully completed, stitched together, perfect model of the entire body. So we've ended up creating a virtual work on an almost epic scale, it feels like now, much larger than we originally anticipated. Our process took a shift from the start, where we were focusing on digitizing movement and extending it into hyperreality. And I'm quite pleased and proud with where we ended up, building sacred virtual spaces in dialogue with the digitized body.
So can you guys, especially since the 3 of you, you're a composer, performer, and then a virtual reality maker, basically, can you talk about how this incorporates science into it? Because that was one of their first questions of how is this really, it wasn't like science like they've seen before.
I mean, it's an interesting question. I mean, science is a bunch of things. One thing that science is, I think, is a process, right? Of dealing with the world around us, and a process of asking questions and trying to ask questions of the world and figure out what it gives us back. And those questions tend to be sort of narrow. And I think that we tend to be asking more open-ended questions, where we're not looking for a specific answer. We're sort of more interested in posing the question itself and trying to deal with the materials of body and movement in virtual space. I mean, look at us. We're all on these screens now. We're not even in the same space together. And this is a new reality that we have to deal with, of what life is like. And I think we're asking some of those questions. We're trying to figure out what those questions are.
So do you think that your research and the things that, especially all the artistic movements and creating the sounds that go with the movements, that this could improve video game development in the future?
Yes, absolutely. I mean, it's interesting. A lot of the technologies being used are the same technologies. We use, for the visualization software, we're using the Unity video game engine, right? That's where this technology comes from. And I think, if anything, my hope would be that people that develop video games look at things like this and they start to think of other possibilities, like Charles was saying, other possibilities for how video games might look and how they might sound and how they might feel.
So our last question is, it's kind of a 2-for-1. How much money, but also time, resource, energy went into making all of this, because it's such on a grand scale?
It was a grant that we initially, for the initial performance, which was Body Full of Time, we had a grant for $3,000, and it took us 6 months to make that piece, which you didn't see, plus the money it took to buy the motion capture suit, which was $4,000, plus no, I think that was basically about it. So about $6,000. For this piece, we got a grant for $9,000 to cover our time and also purchase the VR headsets. And this piece has taken us a year of time.
So I think it's, from a career perspective, it's interesting to realize, and maybe you all haven't thought about this before, that you can have a career in which these are the kinds of things you do. These are the kinds of questions you ask, and these are the kinds of things that you explore. It's a blast. Well, I just want to thank Ms. Thomas's sixth graders, as well as the Time Garden team. Thank you so much for being here today.